We want to solve the system of equations using elimination or the addition method. When using the addition or elimination method, we want to add the two equations together and eliminate one of the variable terms. This indicates for this system, we want either the x squared terms or y squared terms to be opposites before adding. In this case, notice the y squared terms are opposites, and therefore we don't have to multiply one or both equations by a constant. Sometimes we do, but in this case we don't. Let's go ahead and add the two equations together. X squared plus x squared is 2x squared. And then y squared plus negative y squared is 0, equals on the right side, 6 plus 2 is equal to 8. And now we solve for x. We divide both sides by 2. Simplifying, we have x squared equals 4. And now to solve for x, we take the square root of both sides of the equation. We will have a positive and negative solution. To make sure we get both solutions, we include a plus or minus on the right. Simplifying, we have x equals plus or minus the square root of 4, and since the square root of 4 equals 2, we have x equals plus or minus 2. Now we need to determine the corresponding values of y for x equals 2, as well as x equals negative 2. By substituting positive and negative 2 back into one of the equations and solving for y. Let's go ahead and use equation 1 to determine the corresponding y values. So using the equation x squared plus y squared equals 6, let's go ahead and solve the equation for y squared by subtracting x squared on both sides, and we have y squared equals 6 minus x squared. And now let's use x equals positive 2 and solve for y. Replacing x with 2, we have y squared equals 6 minus the square of 2, which indicates y squared is equal to 6 minus 4, which equals 2. So now we know y squared equals 2. We need to, again, square root both sides of the equation to solve for y, and include a plus or minus on the right. Simplifying, we have y equals plus or minus the square root of 2. This indicates when x equals 2, y can be equal to either positive or negative square root 2. Keeping track of our solutions, let's give these solutions as ordered pairs. So far we have two solutions. We have 2 comma square root 2, as well as 2 comma negative square root 2. Because the square root of 2 does not simplify, and we want to give the exact solutions, we don't want to give decimal approximations for square root 2 or negative square root 2. But we're still not done. Remember, x can also equal negative 2. So now we'll solve for y when x equals negative 2. When x is negative 2, we have y squared equals 6 minus the square of negative 2. But the square of negative 2 is 4, giving us 6 minus 4, and therefore y squared equals 2 again. Solving for y, we now know when x equals negative 2, y can equal plus or minus square root 2, which indicates we have two more solutions. We know when x equals negative 2, y can equal square root 2, and if x equals negative 2, y can also equal negative square root 2. The given system of equations has 4 solutions. Before we go, let's verify this graphically. You may recognize x squared plus y squared equals 6 as the equation of a circle, and x squared minus y squared equals 2, the equation of a hyperbola. Recall when solving a system using graphing, each point of intersection represents a solution. Notice the circle and hyperbola have 4 points of intersection. Using Desmos, if we click on the points of intersection, the intersection points appear. However, notice Desmos is giving us decimal approximations for square root 2 and negative square root 2. But on the left, I did enter the square root of 2 just to verify the decimal approximations do represent square root 2 and negative square root 2. The graph verifies our solutions are correct. I hope you found this helpful.